So then when you talk about temperature, it's important to understand what is the absolute zero. So the temperature where the pressure and volume of gas theoretically reach zero is absolute zero. Actually, if temperature like absolute zero is a temperature at which a thermodynamic system has the lowest energy. So it corresponds at negative 273 Celsius degree or minus 459.67 Fahrenheit on the Fahrenheit scale. The motion or the notion that we have that is an ultimate lowest temperature was suggested by the behavior of gas at low pressure. It was noted that the gas seems to contract indefinitely as the temperature decreases. So remember, when the temperature decreases, the volume also start decreasing. The temperature decrease, the volume decrease. Remember the balloon of the photo that I showed before for you. So if it appears that if it's an ideal gas at a constant pressure would reach zero volume at what is now called absolute zero of temperature. Okay, so and all the problems of gas problems we're gonna use Kelvin. Remember, Kelvin, we don't have negative values. 0 Kelvin is the lowest temperature that we can have, the lowest energy of the molecules, the particles. Okay, so ideal gas law. Let's talk about that. Recall that the pressure of a gas is inversely proportional to the volume and directly proportional to the temperature and number of molecules. Here we are talking about Boyle's law. We are talking about Charlie's law. And we are talking about Gay-Lussac law. And here we have Avogadro law. That is about the number of moles. Like you know that when you increase the number of moles, we increase the pressure, the direct proportion. So this is the number of moles. And Boyle, Charlie's law, and Gay-Lussac law, we work the pressure, volume, and temperature, right? So if you introduce a proportional constant here, which is the constant of ideal gas, we can write that P VLP equal R and T divided by V. So, and then we can rearrange and we have the ideal gas law. That is pressure times volume equal number of molecules, that is number of moles. And then we have the constant of the ideal gas and constant of ideal gas. And we have the temperature and Kelvin, okay? And this is the value that R has. And you're gonna find those values in the table of different units as well. But I would love to show you how they get these values. So you don't need to calculate, but I will show you. This value comes from STP conditions. STP conditions, STP conditions. Remember, temperature is equal 0 degrees Celsius and pressure is 1 atm. But remember, we cannot use Celsius, so 0 degrees Celsius is 273 kelvins, right? So when the U, to calculate this, I'm going to use PV and RT, and this is what I want, R, right? So I know R, if I divide both sides by N and T, I'm going to have R equal PV divided by NT. And so if I put it here, the values that I have, so pressure is 1 atm. Remember that 1 mole of any gas occupies 22.4 liters in STP conditions, so 22.4 liters. And I have N, so it's per mole, and I have the temperature 273. If I grab my calculator over here, I'm gonna use my over here. So I have 22.4 22.4 divide by 273, and I have exactly 0.0821. So I have the units over here: liter, ATM, moles, Kelvin. Good? This how you get this number over there. But you don't need to worry, this number will be given for you in the exam, okay? Just to show you how they got that number, because I don't know you, but I always ask myself how they got this formula and how they got this number, where this came from. This is why I'm a research, because I'm really curious about everything. So if you're curious like me, you will never need to memorize anything. So here a very simple example, and it's already solved here. So how many moles of neon gas occupies 2.34 liters at STP? If it tells you this on the test, probably you're gonna be like, okay, it's missing some data over here because I only have the volume. How am I gonna know the number of moles? If they ask the number of moles, I know that I have to use ideal gas laws because I have PV and RT. So R is giving, right? So we know that is 0.0821 liters atmosphere per mole Kelvin. Okay, so but what is the temperature? What is the pressure? How are we going to do this? So I know that 1 mole occupies 22.4 liters. But here they're giving you 34. So I know that cannot be 1 mole because 1 mole occupies 22.4 liters. So okay. So the pressure, STP, I know the pressure is 1 atm, and I know temperature is 273 kelvins. So the only thing I will rearrange over here, so I will divide both sides by RT. So I'm going to have this, and there will be N equal PV divided by RT. Algebra again. So now you put back all the data over here that you have. So, and you're going to have, this is the volume that is the given data, right? So then you have the R, should be given for you. But if it's not there, you know how to calculate. It's pretty easy. So I have the pressure and the temperature. I have everything. So now calculate. See? Number of moles, 0.104 moles, which is pretty small compared to when they said 1 mole occupies 22.4 liters and SCP conditions. Good? So if you know the concepts, it's easy to know if you did it all right. So, and here in this chapter, it's pretty important to know that I need you to absorb this, that what is Dalton law states. So the total pressure will be the sum of all the pressures. The ideal gas law, PV equal nRT. The constant, where this constant come from, is the same formula for the STP conditions. So 1 mole occupies 22.4 liters. I know the pressure is 1 atm and the temperature is 0 degrees Celsius, but we cannot use Celsius. Remember, we're going to use Kelvin, 273 kelvins. Then you can find that value as well if it's not given for you. Okay, so that's it. That's all. Bye for now.